What's good, everybody? Today we're going to learn about how to simplify, add, and subtract rational expressions. So, right now we have these two terms with two parts with unlike denominators. And in order to get a common denominator, the common denominator is just going to be these terms, the denominators multiplied together. So, the common denominator is going to be x times x plus 2. Now, how do we get to the denominator x times x plus 2? Well, for the 3 divided by x part, we're going to multiply by x plus 2 because that's what's missing. It has the x part, but it doesn't have the x plus 2 part. And for the 5 divided by x plus 2 part, it has the x plus 2 part, but it doesn't have the x part. So what you do is, for the left term, you multiply by x plus 2 divided by x plus 2. And you have to multiply the top and the bottom because you have to keep this expression equal. You cannot change this expression. And on the right side, you just multiply by x divided by x. So when you do this, you get this common denominator of x squared plus 2x. And when you have a common denominator, you can combine these two fractions together. So right now, we're just going to FOIL the 3 times x plus 2. So you're going to get 3 times x, which is just 3x, 3 times 2, which is just 2. Now we have the 5 times x part. 5 times x is just 5x. We combine like terms. So we get ax plus 3 divided by x squared plus 2x. Now, some of you still might be confused about what's going on. So let's kind of scale the difficulty down. Let's do an easier problem. We have 1/3 plus 1/2. How would we solve this problem? Well, we would find the common denominator, which is 6, because 3 times 2 is 6. And now, since we know that 1/3, you have to multiply it, the top and the bottom, by 2 to get to the common denominator, which is 6. So when you multiply the top and the bottom by 1/3 by 2, you're going to get 2 over 6. And for the 1/2 part, you have to multiply the top and the bottom by 3 because we know that the common denominator is 2 times 3, which is 6. And it has the 2 part, right? But it's missing the 3 part, the multiplied by 3 part. So you multiply the top and the bottom by 3, and you get 5. What am I talking? You get 3 over 6. And when you add these together, you get 5 over 6. So this is kind of like an easier problem that still uses the same technique we just used in the last problem. Now for this problem, we're going to find the LCM by using prime factorization of these numbers. So for the denominator, how can we break this 6y up? Well, this 6y, this can be represented as y times 3 times 2. And what about the 9? Well, the prime factorization of 9 is just 3 times 3. So you're finding the prime numbers that go into this. And what you want to do is you want to look at your list of the factors and you want to see which one of the lists has the most of a certain number. So in this case, because 6y, it has a 2, and the prime factorization of 9 doesn't have a 2, we include that in our LCM list. Then we see how there's a 3 in the 6y part, but there's a 3 times 3 in the prime factorization of 9, so we include the one where the 3 appears the most, which is 9, the 9 area. So we're going to include 2 times 3 times 3. And then for y, well, y, it appears only in 6y. So we include that as well, because the y appears the most in that list. So now we have 2 times 3 times 3 times y. And when we combine like terms and multiply this together, we're going to get 18y. And that's going to be our LCM. Now, since we know the LCM is 18y, well, what times 6y is 18y? Well, 3. So we have to multiply the top and the bottom by 3 in order for the denominator to go from 6y to 18y. Now, what about 5 over 9? How can we get 5 over 9? How can we get the 9 to be 18y? Well, we have to multiply the 9 by 2y, because 9 times 2y is 18y. So we multiply the top and the bottom of 5 over 9 by 2y, and we multiply the top and the bottom by 5 divided by 6y. We multiply that by 3. And now you see how we have a common denominator. So we can combine these two fractions together, and we get 15 plus 10y divided by 18y. This cannot be simplified any further, so this is our final answer. And that's pretty much it, everyone. Hope y'all have a nice day. Maybe make a video on how to do this with like complex rational numbers. Simplifying complex radical expressions. And yeah, have a nice day, guys.